Welcome back. Solubility equilibrium is the next topic um, that I would like to discuss. It's lesson 7, and we're going to look at equilibrium in solutions. When a salt is dissolved in water and the solution is saturated, we call this an solubility equilibrium. There is an equilibrium between the undissolved salt and its ions in solution. So the first one we're going to look at is a brine solution or a sodium chloride solution. Now the dissociation equation looks like this. Sodium chloride will dissolve in water to form the sodium ions that will be hydrated now, and the chloride ions. And this dissolution process is an endothermic process. So the salt is in equilibrium with the ions. The second one I want us to look at is a potassium dichromate solution. So the dissociation equation for this reaction, now potassium dichromate, K2Cr2O7, is a beautiful orange color, and it would be, the salt will be in equilibrium with potassium ions, and there would be 2 potassium ions for each one potassium dichromate, and Cr2, O7, 2 negative, also aqueous solution, and once again the forward reaction is an endothermic reaction. Next, I want us to discuss the effect of temperature on solutions. Now, because the dissolving process is an endothermic process, according to Le Chatelier's principle, an increase in temperature will make the salt more soluble. The equilibrium will shift to the right. A decrease in temperature will make the salt less soluble, so the equilibrium will shift to the left. And I want us to just look at the sodium chloride situation. Sorry, that should be a clear S. Because the forward reaction is endothermic, an increase in temperature will favor the endothermic reaction. So that would be the forward reaction. So the concentration of the chloride ions will increase, and the concentration of the sodium ions will increase. We can't say anything about the concentration of the sodium chloride because it is a solid, but we can say the amount, the moles of sodium chloride will decrease. We can say that. So the equilibrium will shift to the right. If we look at the potassium dichromate, that is in equilibrium with its salt, its ions in solution, Once again, the forward reaction is endothermic. So a decrease in temperature, according to Le Chatelier's principle, will favor the exothermic reaction. So therefore the reverse reaction the equilibrium shifts to the left, and if the equilibrium shifts to the left, there will be more solid salt precipitated. We can't say concentration, but we can say the moles of the dichromate will increase. The concentration of the potassium ions will decrease, and the concentration of the dichromate ions will decrease. That's why we say the equilibrium shifts to the left. Lastly, I want to discuss the common ion effect. So adding a substance with a common ion to a saturated salt solution will decrease the solubility of the salt. Now, if I've got my sodium chloride solution, saturated solution, and I add some hydrochloric acid solution, what am I actually adding to this solution? Hydrochloric acid solution's got oxonium ions, or hydrogen ions if you want to leave the water part out, and chloride ions. So by adding hydrogen chloride solution to the salt solution, we are increasing the concentration of the chloride ions. Now, Le Chatelier's principle says if something is in equilibrium and you disturb the equilibrium, the reaction that will oppose this disturbance will be favored. So in this case, the increase in the chloride ion, the common ion, will shift the equilibrium to the left. So what will you see in the container with the saturated solution? More sodium chloride crystals will appear, because according to Le Chatelier's principle, the increased concentration of chloride ions will favor the reaction that will oppose or decrease the concentration of chloride ions. And that is the reason for adding the common ion, reducing the solubility of the salt. Lastly, I want to do the example, my example 3 on page 178. It's question number 2 of the think tank there. You've got anhydrous copper chloride, which is yellow, It's dissolved in water, and the color changes to green and then to blue because of the copper being hydrated with water. Okay, so the following experiments is carried out, and we have to say what the effect is on the changes in concentration and use Le Chatelier's principle to explain the color change that will occur. So the first situation, we add sodium chloride. Now sodium chloride has chloride ions in the solution. So you're increasing the concentration of chloride ions. And according to Le Chatelier's principle, the reaction that will decrease or oppose this increase in chloride concentration. So the reaction that will decrease the chloride concentration is favored. So that is the reverse reaction. So the amount of water will increase as the equilibrium shifts to the left. The concentration of the copper chloride will increase, and the concentration of the copper 2+, that's hydrated, will decrease, and after the addition of the sodium chloride, the chloride concentration will attempt to decrease. So it favors the reverse reaction. The turquoise solution turns yellow. The second thing they changed was they added some water. So adding water increases the amount of water. So Le Chatelier says the reaction that will try and decrease the amount of water will be favored. So that is the reaction shifts to the right. So the turquoise solution turns to a blue as more copper 2+ ions are formed. Concentration of chloride will also increase, and your reagents on the left-hand side of the equation, the copper chloride and the water, will decrease. The third point is they add sulfuric acid. Now sulfuric acid is a dehydrating agent. So it removes water. If we listen to Le Chatelier's principle, the reaction that will form or release more water will be favored. So the reverse reaction is favored. So your concentration of copper chloride ions in solution will increase. Your moles of water will increase. Your copper 2+ concentration will decrease, and that your copper chloride ion concentration will also decrease. The last thing they look at, and my time's running out, is what will happen to the color that will if it's heated, and I think you should do that yourself.